in this part of chemistry, we are going to talk about organic chemistry. And mainly in organic chemistry, we're going to talk about hydrocarbons. And in hydrocarbons, there is alkanes and alkenes and alkynes. We're going to focus mainly on alkanes. So what are hydrocarbons? Hydrocarbons are compounds that contain hydrogen and carbon. That's why you call them hydrocarbons. And in general, hydrocarbons, they are divided into what? Main two groups. One of them is saturated, and one of them is what? Unsaturated. Saturated here, it is alkanes. And unsaturated, it can be alkenes, it can be alkynes. Good. Mainly, we're going to focus on this part, which is saturated and alkanes. And we're going to explain what does it mean, saturated and unsaturated. Okay, alkanes, this one is very important to remember. Alkanes, and here alkenes, and here alkynes. These three groups are very important to remember. And there is fourth one. It is not just one of these ones. It's just like partial group, which is alkyls, and we're going to understand it. So alkenes, what is it? For each one of these ones, we need to understand what is their properties and what is its general formula and how to name them. And this is what we are going to study in hydrocarbons in general in this video and in the next video. So you're going to understand the difference between alkanes and alkenes and alkynes, and each one has a general formula and we need to understand it, and then how to name each of them. The general formula of alkanes is CnH2n plus 2. And we're going to explain how this one can be applied. Okay, the second one here is CnH2n only. While alkynes, it is CnH2n minus 2. These general formulas are very important. So Cn here, N is a number, and it is the number of carbon atoms. N. So CnH is 2n, that means twice the n plus 2. While for alkenes, it is CnH2n only. While for alkynes, it is CnH2n minus 2. Okay, here now, what is, if n is 1? If n is 1, what will be this one here now? You put here is 1 and here is 1. So it's going to be C and here 1. No need to write 1. And H will be here 2 times 1, 2. 2 plus 2, 4. So that means it's going to be H what? 4. Okay, what about when n equals 3? For example, in this case, C3, here it's going to be what? 3. So that means C will be with 3 here. And H, it's going to be here, n is 3. 3 times 2 is 6. 6 plus 2 is 8. So that means it's going to be what? 8. This one now, it has a name, and this one has a name. We can understand them now. Okay, here now, it's the same when you apply it then on the chemical video. For n, we put it if n is 1, we're going to see that H is just will be twice. Okay, so as you see here, when C is 1 here, 1 carbon atom, it has 4 hydrogen atoms. Good. When C here is 3, it has what? It has 8 hydrogen atoms. We're going to understand this one here. Just memorize that. On this video mainly, we're going to talk about this part, and the next video we're going to talk about these two parts. Okay, now for alkanes that we are going to explain now, which is what? Alkanes. And we said its general formula is CnH2n plus 2. Good. If n is 1, when n is 1, okay, here when n, here is n, get. When n here is 1, get. What will we have if n is 1? If n is 1, that means it's going to be C1, no need to write it, and H, it's going to be here, 2 times 1, 2 plus 2, it's going to be what? 4. Okay, what about when n is 2? When n is 2, that means C is going to be 2 here, and then 2 here, you multiply it by 2, which is n is 2. 2 times 2, 4. 4 plus 2 will be what? Will be 6. Good. What about here if n is 3? It's gonna be C3. And what will be H? H will be twice the 3 plus 2. So 3 times 2, 6 plus 2 is gonna be what? 8. Okay, what about when n is 4? When n is 4, as you see, it's gonna be C4. H will be 4 times 2, which is 8, plus 2, that is what? That is 10. Good. What about when it is 5? Okay, when it is 5, it's gonna be C5, and here H is gonna be 5 times 2. It's gonna be 10 plus 2 is gonna be what? It's gonna be 12. Okay, what is these ones now? In each one, based on number of carbon atoms, it has a name. So this one now, what is its name? The first one, its name is what? Methane. Methane. And you need to memorize these ones here. The second one here is ethane. Okay. Remember that the end here is A-N-E. The end here is A-N-E. Why? Because the end here is what? A-N-E. Look, A-N-E, same thing here, A-N-E. Third one is going to be called what? Propane. Also A-N-E. Then here is going to be what? Butane. Good. Which next one now will be? Pentane. Pentane. So you link the name here, which is like pentane, with how many carbon atoms is there, with 5 here. As you see, 5 carbon atoms, it is pentane. 4 butane, and 3 propane, and 2 ethane, and 1 methane. Okay, if we continue now, when n is, and this is n now. Okay, what about when n is 6 here? And here is 7, 8, 9, 10. Okay, when n is 6, that means it's going to be C6 here, and H is going to be 6. You put it instead of n. N times 2, it's going to be 6 times 2. It's going to be 12. 12 plus 2 is going to be what? 14. Okay, what about if it is 7 here? It's going to be C7. And H will be 7 times 2. It's going to be 14 plus 2 is going to be what? 16. And here when n is 8, so that means C8 here. And H will be twice the 8, which is 16 plus 2 is going to be what? 18. Okay, here it's going to be C9. And H here is going to be 9 times 2, 18 plus 2 is going to be what? 20. And here it's going to be C10. So H will be 10 times 2, 20 plus 2 is going to be 22. Okay, what's the names now? You need to remember this one now is called what? Hexane. This one is hexane. As you see, the end is A-N-E. And here now, they're going to be what? Heptane. Heptane. And as you see, it is A-N-E. And this one now is octane. Octane, A-N-E. Then this one will be what? Nonane. And the last one will be what? Decay. Good. So these ones we need to remember. These 10 compounds, these 10 alkanes, we need to memorize them. And we need to remember each one, what is its molecular formula. This one now, remember that these ones called molecular what? Formulas. Molecular formulas, and these one, their names. So we need to remember the name of each of these 10 and its molecular formula, which is CH4 or C2H6. And we need to remember number of carbon atoms, how many carbon atoms it has. And to find then how many hydrogen atoms, just you multiply the carbon atoms times 2 and you add 2. In this case, you're going to find how many hydrogen atoms. So again, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. These ones you need to memorize them and their molecular formula. If you didn't memorize them, you can stop the video, then memorize them till you are okay, then you move to the next point. Then move now to the next point where we start now before you memorize these ones and their molecular structure. This one is called molecular what? Formula. Molecular what? Formula for each of this compound. Okay. We go now to the next point. Okay, what is the next point now? We're going to take examples of these ones, examples of these ones, how we can change its molecular formula. Okay, if we are talking about now CH4, and this is, as we know, is what? Is methane. Good. Methane. Good. This methane now, with the end A and E, I mean alkane. And as you see, here is 1. And this one, it means 1 times 2 is 2 plus 2 is going to be what? 4. So that means it is on the general formula Cn and H2n plus 2. So that means whenever you see this one is applied here, this general formula applied for this form, which is CH4, that means this is alkane. This is what? Alkane. So always, if you want to know whether a given compound, is it alkane or alkene or alkyl or alkyne, you need to remember the formula of it, which is a general formula. Good. Here now, C1H4. As we know, carbon atom is on the 14th group on the periodic table. And when it makes compounds, it makes compounds by sharing electrons. That means by making covalent bond, not ionic bond, just by sharing the electrons, which is covalent bond. Okay, carbon atom now, how many electrons are there in its valence electrons? It has 4 valence electrons. So these 4 valence electrons, if we just make them as points around the carbon like Lewis structure, you're going to see these ones has 4 carbon atoms in the valence electron. And for carbon, in order to feel it's okay, to feel stable or to be stable, it has to have 8 electrons around it. So now it has only 4. So that means carbon atom now is ready to share these 4 with other 4 electrons to feel it has 8 electrons. What will happen now? We're going to give here 1 hydrogen atom. And as we know, a hydrogen atom, it has 1 electron in its valence. And it is number 1 element in the periodic table. So it has here 1 electron. And this is 1 hydrogen and it has here electron. And this is 1 hydrogen, it has here electron. And here 1 hydrogen, it has what? Here electron. What will happen now? These 2 electrons will make a bond. And these 2 electrons will make a bond. And these ones now will make a bond. And these ones now will make a bond. Okay, now this bond, it means sharing of these electrons. So the carbon will share 1 electron to 1 atom of hydrogen, and the hydrogen will share 1 electron. Okay, what will happen now? What will happen exactly? The carbon will feel this is its surroundings. You see? The carbon atom will feel that this is its surrounding. How many now electrons are surrounded or surround carbon atom? How many you see now? 8 carbon atoms. 8 electrons. So these 8 electrons now for the carbon atom, it will feel stable since it has what? 8, like the same if it is in its valence electrons. And hydrogen atom, it will feel like this is its surrounding. So it has 2 electrons. That means it has like if it has same 2 electrons on the first energy level. Good. So these ones now, they're going to be stable in this case. So what do you need to remember from this one now is carbon atom, it can make 4 bonds. Can it make more than 4? No. It can make here, for hydrocarbons, it can make 4 bonds in our studies. So we need to remember the number 4 for carbon atom, it makes 4 bonds. So in all hydrocarbons, whether is it alkane or alkene or alkyne or alkyl, each carbon atom, we are talking about each carbon atom, it will make 4 bonds. Good. So look here now. Now this formula now, look here now what types of formulas we have here. This formula now that is here, CH4, this is called molecular formula. And the molecular formula, it gives us how many carbon atoms and how many hydrogen carbon atoms are there, but it doesn't give us the structure. Just to give us the number, C1 and H4. But this one now, as you see, this is the structure of methane. So methane, its structure is like this. Carbon atom is in the middle and around it 4 hydrogen atoms. Good. We're going to make it easier, we're going to understand another one here. We're going to talk about what? Ethane. So ethane now, ethane as we know, it has 2 carbon atoms, and its molecular formula is C2, and H will be 2 times 2 is 4 plus 2 is going to be what, 6. So this is now its molecular formula. Okay, how can I write its structure now? Okay, it can be, by the way, this one now, you can write it like this. Look, C3, C, H3, and here CH3. Am I wrong if I write it like this? No, it's still right. Okay, it means here, how many carbon atoms? 1, 2, so 2 carbon atoms. And how many hydrogen here? Here is 3 and here is 3. So isn't it the same like this one here? Yes. But here now, this one, it means a structural formula. This one is what? Molecular formula. A structural formula gives like a sign how the order of these ones, how the structure of these ones are going. Okay, now, how this one now, how it works. How this one works. Look, here it means 1 carbon atom. Memorize that. This is now 1 carbon atom. And around it are 3 hydrogen atoms. Good. Okay, if this 1 carbon atom that is here, look, this carbon atom now, there around it, as you see, 3 hydrogen atoms. Okay, what about the second carbon atom? Also around it, what? 3 hydrogen atoms. Good. But didn't we say that carbon atom, it has to have 4 bonds around it? Not 3, 4. Okay, where will be the 4th bond? Where will be the 4th bond? So look, this one now is the first carbon atom. We're gonna draw it here. And this one here, the carbon atom, we're gonna put it what? Here as well. Okay, good. Now what will happen here? This first one, it has 3 hydrogen atoms. So 1, and here is 2, and here is 3. Okay, now this carbon atom, now it has 3 bonds with 3 hydrogen atoms. And where will be the 4th bond? And memorize that the 4th bond will be with the second carbon atom. You see? And here now, as you see, this carbon atom now, it has 1 hydrogen here, and 1 hydrogen here, and 1 hydrogen here. So as you see now, this one now is ethane. So this one is ethane. Or it can be written this way, or it can be this way. So then it is still ethane. As you see, 2 carbon atoms, and around it 6 hydrogen atoms. Good. And each carbon atom, it has 4 bonds. Each carbon atom, it has 4 bonds. And these bonds are singular bonds. They are not double bonds. Double bonds, like if it is 2 bonds together, like here, like carbon here, sometimes a carbon atom and another carbon atom, they have double bonds. No, in alkanes, all the bonds are singular. And memorize that, all of them singular. And that's why we call alkanes saturated. Why do we call alkanes saturated? Why? Because it has only single bonds. That means all the bonds are single. No double bond, no triple bond in alkanes. So that's we call it what? Saturated. If there is double bond or triple bond, this compound is unsaturated then called. Good. So alkanes, as we said now, all the bonds are singular. That means single bonds. That means this is what? Saturated. And as you see, for each one now, it has, for each carbon atom, it has 4 bonds around it, and it has all of them, they are what? Single. Okay, if we take another one as well, just extra. If we talk, for example, about what? Pentane. If we talk about what? Pentane. And this is now alkane. Pentane, as we know from the previous table, it has 5 carbon atoms. So its molecular formula, it is C5, and here H will be 5 times 2, 10, plus 2 is going to be what? 12. This is its molecular formula, and the molecular formula just gives us how many carbon atoms, how many hydrogen atoms, but it doesn't give us what is its structure. Okay, if we write the structure now, we're going to write them like this. C, the first C, second C, third, fourth, fifth C. Good. We're going to draw them this way. Then the first carbon atom, usually the first one, it has 3 hydrogen atoms, you see? And the last one, it has 3 hydrogen atoms. Keep that in mind. And what about those 3 in the middle? This is now not just for pentane, for all alkanes. For all alkanes, for the 10 alkanes, you can draw its structure formula like this way. The first carbon atom and the last, around the 3 carbon atoms. But what about the middle ones? The middle carbon atoms, each one it has 2 hydrogens. It has what? 2 hydrogens. Okay, now, if I draw the general structure of pentane, how it's gonna be? Look, this one now is 1C, 2, 3, 4, 5. These ones 5 carbon atoms. And remember, since it is alkane, all the carbon atoms bonded by themselves by only 1 single bond. So that means this is for all ANE, all alkanes. So that means this one now 1 single bond, single bond, single bond. Good. And remember now, each carbon atom has to have 4 bonds. Has to have what? 4 bonds. Okay, if we are talking about the first carbon atom here, it has now 1 bond with the right carbon atom. That means it should has now 3 more bonds. Good. Okay, what about the second carbon atom? It has to have 2 more bonds. Now it has 4 bonds. This one has to have 2 more bonds. And this one has to have 2 more. And the last one has to have what? 3 more bonds. Okay, these ones now will be filled by what? By hydrogen. So as you see now, hydrogen here, hydrogen here, hydrogen here, and this is hydrogen here. This is hydrogen, this is hydrogen, this is here hydrogen, and this is hydrogen, and here hydrogen, and here hydrogen. Now, is this one now achieved? Are these ones here achieved? Okay. Are there 5 carbon atoms? Yes, there are 5 carbon atoms. Are there 12 hydrogen atoms? Yes, there are 12 hydrogen atoms. Are all the bonds around each carbon atom is singular? Yes, each bond, as you see around, all the bonds around each carbon atom is singular. So that means, as you said, this is what? Pentane. So pentane, it can be, memorize that, it can be this way, C5H12. It can be this way. It can be this way. It can be as well, I can repeat, by the way, you can repeat, okay, you can, the repeated ones, you can combine them. As you see here now, CH2 and CH2, these middle ones, and here CH2, how many of them? 3. They are repeated. So that means this one now, look, I can now, look how I do it. CH3, just I write it, which means this one, you see? Now CH2 here, CH2, how many times it is repeated? How many times here it is repeated, as you see? It is repeated 3 times. So you can make here, parenthesis, and you write here 3. That means it is repeated 3 times. Now we finished the first one, and the second one, and the third one, and the fourth. Now what is left? Just CH what? CH what? 3. So that means this is now is called condensed structural formula. So that means this one now condensed, like why you call it condensed? Like if we combine those repeated ones together in one bracket, then we wrote the number here to show how many CH2 is repeated in the middle. So 3 of them, as you see here, repeated in the middle. So you write here 3. I hope that is clear. So pentane, it can be, memorize that, it can be this way, 1 or 2 or 3 or 4 ways to write or to draw pentane. And I hope that is clear now, and you understand now how to name or what are these 10 hydrocarbons, which is alkanes. We know their names, we know how many carbon atoms, we know how many hydrogen atoms, we know how it can be their structure and their molecular what? Formula. Okay, and we need to remember, as we said, alkanes are saturated and they have only single bonds, so we call them what? Saturated, and they have only 1 single bond. And to know that, alkanes are not polar compounds, Since they are not polar, we're going to understand polar compounds when we study alcohol and carboxylic acids on the coming videos. But remember now, alkanes are not polar, That means they are not polar. That means when the electrons are shared, they are not attracted by one side more. So that means, remember, alkanes are not polar compounds, so they are insoluble in water, because water is polar. So what dissolves in water is only what? Polar compounds, and alkanes is not polar compound. And remember also one idea. For example, oil, it has many hydrocarbons, and these many hydrocarbons, many chains, many different chains. How do we distribute them? How do we extract different molecules or different hydrocarbons from oil? By something called frictional what? Distillation. That means we have like a tower here, and we heat here the hydrocarbons, and then based on their boiling point, they go from each point when they get when they become like a steam or a vapor. Each one will go out from a place. So that means here we distract them for each part of them based on its boiling point by evaporation, then distribute them for each one based on its number of carbon atoms and its boiling point. Good. If we know now, we're going to go to another point. If we are talking about alkanes, these straight lines here, alkanes, will they be always like straight lines, or they can be shaped in another way? They can be shaped like like polygons. They can. And we're going to understand here. Look, for example, now if we are talking about butane, if we are talking about what? Butane. Butane, as we know, it has C4, and H will be 4 times 2 will be 8 plus 2. That means it's going to be what? 10. Good. This one here, as we know, can write it like C, 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 C. Good. Here, like this. And as we know, the first one, we have 3 carbon atoms, hydrogen atoms. Here is 2, and here is what? 3. Good. So this one is what? Butane. This one is butane. Okay. This butane now, it has 4 carbon atoms. If these carbon atoms now, we don't draw them in a straight line. We can draw them like 4 corners. Okay, yes, we can. Look how we're going to do that. We're going to draw 1 carbon atom here, 1 carbon atom in this part, and 1 carbon here, and 1 carbon here, and 1 carbon here. Good. Now, each carbon now with another carbon, it has singular bonds. So this is singular bond, singular bond, singular bond, singular bond. Good. And as we know now, each carbon atom, it has 4 bonds. It has 4 bonds. So that means this one now will have more 2, and here is more 2, and here is more 2, and here is what? More 2. And these 2, all of them, are going to be filled by what? By hydrogen. By hydrogen. Good. Like this, hydrogen, as you see, like this, hydrogen here, here hydrogen, and here hydrogen. Now I'll ask you a question. Is the number of carbon atoms of this shape, is it the same like this shape? Yes. How many? 4 carbon atoms, 4 carbon atoms. Good. Another question. Is the number of hydrogen atoms in that shape, like the previous shape? Here, how many hydrogen atoms? As you know, hydrogen atoms, how many they are? How many hydrogen atoms? There are 12. There are 10. Sorry, here there are what? 10. As we said here, there are what? 10. But here, how many hydrogen atoms in this part? In this shape? How many? How many hydrogen atoms? If you count each corner, it has 2 hydrogen atoms. So that means it has 8. It has 8. Good. And all of them, all these ones now are singular bonds. Okay, what happened? Look here, shabab. This shape, imagine now you rotate this bond. Imagine now you rotate it to be with this hydrogen atom. You see? Imagine you rotate it like this to make it like a circle. When you rotate it, this hydrogen will be cancelled and this hydrogen will be cancelled, and the bond here will be attracted to the bond here on the left. You see? They're going to be like that, this one. That means they're going to be two hydrogen atoms will be removed. When we are going to make cyclo shapes like polygons. So this one now, as you see, what is this shape now? This shape now, how it is exactly? We can redraw this shape just like a square, you see? If we write you in hydrocarbons just a square, and we tell you this one now, what is its name? This is square now. We'll not say it is a square because this is not math, this is hydrocarbons. So that means when you see a square, remember in each corner there is what? Carbon atom. In each corner what? There is carbon atom. That means how many carbon atoms? 4 carbon atoms. And what is the alkane that it has 4 carbon atoms? Okay, how I know if it is alkane or alkene? As you see, since there are 4 carbon atoms in the corner and the bond between each 2 carbon atoms is singular, right? So this is alkane. Okay, what alkane that it has 4 carbon atoms? It is butane. Thank you. So this one is what? Butane. Get this is what? Butane. Okay, but how do I know that this is butane and this is butane? You see, how I know what's the difference between them when just I mention the name? This one here, you need to add a word cyclo before it. You add to it what? Cyclo. So this one is called what? Cyclobutane. Cyclobutane. So that means alkanes, propane, butane, pentane, hexane, all these ones, they can make polygons. They can make like what? Cyclo shapes. So these ones now, then we add the word cyclo before what? Before them. And remember, the cyclo now, this is structural. Look, this one now is a structural formula of cyclobutane. If I'm telling you now what is the molecular formula of cyclobutane, you're going to write it like C4 and H what? And H8. So this one now, when I write it to you like this, it is also cyclobutane. You're going to say, okay, but this is now, it means CN and H2N. It is like alkene. I'm going to tell you, yes, alkene and cycloalkanes, they have same molecular formula, but they don't have the same structural what? Formula. And I hope that is what? That is clear. And we understand how to name these ones. Okay, if I tell you now, this one is the name of the triangle. Okay, you're going to say, since it is triangle, that means in each corner there is a carbon atom. So that means there are what? 3 carbon atoms. Which alkane that it has 3 carbon atoms? It is methane, ethane, methane, ethane, propane. So that means you're going to say this is what? Propane, right? Just by writing it. Okay, if I tell you 1, 2, 3, 4, like this here. Now what is this one? Now this one is pentagon, like pentagon, right? That means 5 corners. Since it has 5 corners, that means in each corner, even if it's not mentioned, I understand that in each corner there is what? There is carbon atom. In each corner there is carbon atom. That means this is what? Pentane. This is pentane because now it is alkane because only one singular bond. But if I write you like this, that means here is double bond. So when it is double bond, that means it is not alkane. But so cycloalkanes, they have only single bonds between these corners that represent number of carbon atoms. Okay, last point of the video of today. We're gonna understand how to name these alkanes and cycloalkanes. Okay, just to take example, here we have C, C, C. So that means we have now 3 carbon atoms. And as we know, each carbon atom has 4 bonds. As you see, each carbon atom has 4 bonds. And we know that this one is what? Hydrogen for each one. Hydrogen what? For each one. Here, there is what? Hydrogen. Good. This one now is hydrogen atom. And this one now we call 3 carbon atoms. So methane, ethane, propane. So this one is propane. This one is what? Propane. Okay, what would happen if I do the following? If I erase this hydrogen, you see it? Okay, I'll erase this hydrogen. And instead of this hydrogen, look what I'm going to do. I'm going to draw another carbon atom here. okay? And this carbon atom, I'm gonna draw for it here H. So 2 bonds now. And I draw here for it 1 H here. Good. Then I'm gonna draw here another carbon atom. And I'm gonna draw here, look, H, H, H. What I did now. Look at this one now. Is now this one is still propane or is it changed? Is it still propane or it is changed? Okay, look here now. How do I name this one? Look, to name this one now, to name it, look here, how can we change it? By the way, you can change the hydrogen atom in one carbon of the same, on the same carbon atom. You can change its chain. What do I mean? Look, I'm gonna redraw it again, but I'm gonna focus on this one here. So that means I'm gonna redraw it here, C, which is as you see here. So that means these ones now, the first two, so hydrogen, 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 hydrogen. Okay, this is now the first one. I'm talking about the first carbon atom and the second carbon atom. So I draw them here. I redraw them here. Okay, and now I redraw the third one. You look, I draw the third one, which is here, the number 3. But look here what I'm gonna do now. I'm gonna do something. I'm gonna do this chain that is here, exactly, look, that is here. I'm gonna take it from this place and I write it instead of this hydrogen, you see? And this hydrogen, I'm gonna write it there. So that means now this hydrogen, I'm gonna write it here up. And the hydrogen that is down here, I write it as it is. Now I bring this chain. Okay, when I bring it here, remember that you can also switch these ones. This one here, you put it instead of this hydrogen, and this hydrogen, you put it here. What you do get? You will get a chain here and carbon atom, and here is hydrogen, you see? And here is hydrogen, and there is here hydrogen, as you see, and here is hydrogen, and here is hydrogen. What it becomes now, as you see, it becomes similar to what? This one now, it becomes similar to what? So how many carbon atoms now you're gonna see? 1, 2, 3, 4, 5. So it becomes what? Pentane. It becomes what? Pentane. So whether is it drawn this way, or this way, it's still called pentane. Okay, how do I know it's pentane? So when you name alkanes, okay, what to do? Just go to see the longest chain. Look, longest chain without removing up, without taking up your finger. I'm gonna draw, look, I'm gonna draw what? A line. Look, I'm drawing a line, you see? And the line here, I'm going on the carbon atoms, you see? The carbon atoms, you see? Okay. As long as you take one line on the carbon atoms, just count number of carbon atoms on this longest line. How many carbon atoms here? 1, 2, 3, 4, 5. So that means here, since there are 5 carbon atoms and all of them singular bonds, so this is pentane. So no need to redraw it this way. Just as long as it is like this way, that means this is still what? Pentane. Remember that this is pentane. So pentane, it can be this way, it can be this way. That means that I'm giving you an example of pentane, but I'm talking about in general, whether is it hexane, octane, nonane, decane, propane, whatever is the name of alkane. So that means you can draw it what? In different ways. Okay, we're gonna take another example. If I have 5 or I have 7 carbon atoms, can I draw them like this? 1, 2, 3, 4, 5, 6, 7. Can I draw them this way? Yes. Okay, look here now. As you see, each carbon atom, it has singular bond with the neighboring carbon atom. And each carbon atom has 4 bonds. Get 4 bonds, as you see, each one has 4 bonds. And these bonds now are filled with what? With hydrogen. So there is hydrogen, 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 as you see here, hydrogen. This is hydrogen, here is hydrogen, here is hydrogen, hydrogen, here is hydrogen, hydrogen. Same thing here, here. Okay, get as you see. How many carbon atoms now? If you see how many carbon atoms, there are 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms. Get all of them singular bonds? Yes, all of them singular bonds. So this is what? Pentane. And as you see, how many hydrogen atoms are around it? As we know from Cn, which is CnH2n plus 2, which is the general formula for alkanes, ANE. So that means here there are 7 carbon atoms, so C7. So H will be double the 7, 14 plus 2, 16. If you count them here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you're going to see them, they are what? 16 hydrogen atoms. So then even if it is like this structure, as long as each carbon atom is bonded to the neighboring carbon atom by one single bond, it's still alkane. But these ones, in general, we named them here in related to our lessons. We beginning them the same, just pentane. Pentane, as long as we go on number of carbon atoms. Okay, these ones now we understand how to name them now based on number of carbon. But look here now, we're going to take another one here now, how to name it. If I have here carbon, 2 carbons, 3 carbons, 4 carbons, and the previous one, if you remember the previous one, I connected the group on the further one carbon atoms, but now I'm gonna do it here. Look, we're gonna do here, as we know, each carbon atom has 4, and these ones, it means with hydrogen. It means they are filled with hydrogen. But what are you gonna do here? I'm gonna write here C, and this C now with 2, then another C here with also. Here now, all of these ones are hydrogen, as we know. Even if they are not written as hydrogen, you're going to fill them by what? By hydrogen. So this is hydrogen for this one, and here, this is hydrogen for this one here, hydrogen. So each carbon, no, this one is not because it's bonded to the upper one. Okay, how do I name this one now? How do I name this compound? How do I name this compound? Look, to name this one now, first step, go to see which one is the longest chain. Pay attention to this part. Go to the longest chain of carbon atoms. Okay, if I make a chain, when you make a chain, you make a line, you go with your finger by a line and don't remove don't take up your finger. So let me say go this way, you see? Okay, if I go this way, look, I stopped here. Is there now another carbon atom I can go to it here that is attached to this carbon atom? No, because this now last carbon atom here in this chain, it is bonded to 3 hydrogen atoms as you see around it. So there's no more carbon atoms, so I stop here. How many carbon atoms here? How many in this chain? 1, 2, 3, 4 carbon atoms. This chain now, we call it pink chain. We call it what? Pink chain, and it has what? 4 carbon atoms. Okay, we're gonna make another chain. We're gonna make it, we're gonna take it like white chain, white. Okay, if you go to the white chain, we're gonna draw this chain. You see what, like, this now is a chain, and here I will not go right, I'll go up. You see, I can go up as long as I'm not removing my finger. Okay, get this white chain now, which is the white chain. Okay, how many carbon atoms are there if you count them? 1, 2, 3, 4, 5. 5 carbon atoms. So in this case now, you should depend on the longest chain. So that means which chain now is right, the pink or the white? The white is right. The white is right since it is the longest chain. Okay, the longest now chain, how many carbon atoms is it? 5. So that means mainly this compound is a pentane. Okay, but when I say pentane, just I named the carbon atoms, they are on the white line, on the white line. So is there any carbon atom that is not on the white line? Yes. Which carbon atom is not on the white line? This carbon atom, you see? So this carbon atom now, it is not attached to it is not on the white line. So that means now this one, I need to name it alone. I need to name it what? Alone. So this one now, it has one carbon atom. That means it is methane, but it has only 3 hydrogens, not 4. If it has 4 hydrogens, it is methane. It is what? So that means CH4, this is methane. Memorize that. This is what? Methane. But if it has CH3 only and 1 bond like this, so this one is called alkyl. And it is called what? Methyl. So that means this one now is methyl. So this one here is also what? Methyl. So in this case now, I have methyl that is attached into what? Into the main compound, which is what? Pentane. So that means I have to add here what? Methyl. What? Methyl. I write the substituent before the main what? Compound, which is pentane. So I have now methyl pentane. Now, when I have methyl pentane, I have to specify in which carbon atom the methyl is attached. That means you need to number the carbon atoms in the chain. Okay, how I number them? Okay, if I number them like this, 1, 2, 3, 4, 5. In this case, the methyl here is attached to which carbon atom? To number 3. To number what? 3. Okay, this is one idea. Can I number it in another way? Yes, I can number them in another way. The goal in numbering is to get the least number for the carbon atom that this alkyl is attached to it. So if I number it from here, 1, 2, 3, 4, 5. So as you see here now, alkyl, which is methyl, is still on number 3. So that means here I write 3, and to separate letters from numbers, you put what? Heaven. So that means here you write 3, just to make it here closer, 3 methyl pentane. So this now is called 3 methyl pentane. 3 methyl pentane. Okay, we take more examples. If we are talking about CH3, and here is CH2, and here we write CH3. And what we're going to do here in this case, this one here, this carbon atom, when we write 2 hydrogens, that means these 2 hydrogens are here. And these ones now, when you write 3, that means these ones are here. These ones, when you write 2, they means they are here. This one here, 3, that means they are here exactly in the carbon atom. But we didn't write them. But it means this one here. Good, it means here, this one. Good. What we'll do now, we will erase these 2 hydrogen atoms from here. We'll erase them, okay? And we can now draw the bond that is between the carbon atoms. That means these carbon atoms are like a chain. Each one is attached to the neighboring carbon atom by 1. And we write here 2 hydrogens. Now this carbon atom that is here, it is attached by how many bonds? How many bonds around it? 4 bonds. Where are these 4 bonds? One of them to the right here, and one of them is here, and one of them is here, and one of them is to this carbon atom, because these 3 hydrogen atoms, even if we write them here, but this is not their places. Their places are here. That means there is a bond between what? Here, this one was carbon atoms. Great. Okay, then we write here hydrogen. Okay, and on this place, we're going to write what? CH3. Okay, again, if we have CnH2n plus 2, this is alkane. But if we write just plus 1, this is called alkyl. Remember that. This is what? Alkyl. So alkyl is CnH2n plus 1, and there is 1 single bond is still there. 1 single bond is not attached. So this one now, alkyl. The alkyl, they are not existing by themselves alone, but they are attached into main compounds. So this one here, as you see, CH3, it is called alkyl. That means since it is alkyl, YL in the end, so that means this one is called what? It's called the lone methyl. So that means YL in the end. So this one is methyl. Thank you. And this methyl now is attached to what? To this one here, you see? So what is now this main compound? How many carbon atoms? 4. So that means this one is what? Butane. Thank you. This one is butane. And the methyl is attached to the butane. So we write them butane as a general name for all this one. We write butane, and before butane, we write this, what? Alkyl. So that means it is, methyl, get methyl butane. But now we need to know on which number of carbon atom is it. So if I number them now, look, if I number carbon atoms of butane, if I number them here, number 1, number 2, number 3, number 4. In this case now, the attached alkyl is attached to what carbon atom? To carbon atom number 3. Okay, when numbering, we need to number them where this attached with this carbon atom has to have the smallest number possible. So now instead of numbering now from right to left, okay, we're gonna number them from left to right. I'm gonna use yellow color. I can number them now 1, look, 2, 3, 4. So in this case now, this carbon atom will take number what? Number 2. So that means this numbering by yellow is the right one. So numbering, you can number them from any side, but make sure the goal of numbering is the carbon atom which this alkyl is attached to it, it has to take the smallest possible number. So that means now numbering from left to right, with this one it takes 2, this is the right way. So that means we write 2, number 2 carbon atom, as this is going to be 2-methyl butane, which is a name for what? For this chain, which is what? For this chain. Okay, last one, we take it here as example of numbering what? Alkanes, and you're going to take then 2 or 3 examples of how to name cycloalkanes. Good. If I have this one here, CH3, good. And here we have CH2, great. And here we have CH2, great. And here we have CH3, great. And here, okay, we make this one 2. And here we write CH3, and here we write CH3. How can we name this compound? How can we name this compound? And as you know, each carbon atom in it has 4 bonds. And you need to remember where these 4 bonds are. This one now, it has 4 bonds. Where are the 4 bonds are? 3 bonds with 3 hydrogens and 1 bond with this carbon atom, you see? And this one now, it has 4 bonds. Where are the 4 bonds? 1 to the left carbon atom and 1 to the right carbon atom and 2 to these 2 hydrogens where they are here. Mainly they are here, you see, but we write them here, but they don't mean this is their place. Their place is here because here is the bond to the other carbon atom. Good. So even if we write them now this way, but we understand their places. We understand the places of the bonds. Good. Now, to number or to name this compound, first step, as we said, you need to search for the longest chain. The longest chain. Okay, I can make, some students will get, oh, okay, this is the longest chain. How many carbon atoms on it? 4. No, this is not the longest chain. Who said that the longest chain, it has to be straight line? No one says it has to be straight line. So it has to go from the end, the carbon atom that is at the end, to another carbon atom that is on the other end. Just with one movement of your finger without taking it or without making jump by your finger. Okay, that means in this case now, we're going to start from here. You see, this is now a chain. You see, how many carbon atoms now in this chain? How many? This green now, we're going to call it green, green chain. How many carbon atoms? 1, 2, 3, 4, 5. So it has 5 carbon atoms. Okay, can we make another chain? Yes. Okay, we're going to make another chain. Another chain, we're going to move this way, you see, like this. And we go here. How many now for pink now? How many carbons there? As you see, also 5 carbons. 1, 2, 3, 4, 5. Is there another chain? Yes, we're going to make it that is red. Okay, ready chain. We're gonna move this way, you see? From the end to the end. So this red now has how many carbon atoms? 3. So that means now, which chain I depend on? Again, you depend on the longest chain. The longest chain, either the pink one or the green one. Okay, but it's easier for you just to use what? To use the green one, because it's just almost like a straight line. So that means as long as it is going to be like a straight, it's good. So now this green now, as you see, this green, it has how many now carbon atoms in the green? 5. So that means what is the main compound that these green chain or this green chain is on them? It is 5 carbon atoms, so, and all of them are singular. So this is what is pentane. So it is what? Mainly pentane. And pentane now we are talking about what? We are talking about these carbon atoms. I finished them. So when I write just pentane, that means I'm talking about all the carbon atoms that the green which line or chain moved on them. Okay, what is left? What is not there on the green one? It is this one still is. And this one now, CH3, we call this is what? This is methyl. This is what? Methyl, which is alkyl, which is what? Alkyl, right? And alkyl is a group that you attach it. You attach it to main compounds. So that means this one is methyl. So you add here what? Methyl. Good. This is what? Methyl. And now, on which carbon atom the methyl is attached to? In which carbon atom? So that means you need to number carbon atoms. Can you number carbon atoms like this? 1, 2, 3, 4, 5? Okay, if I number them this way, that means the carbon atom which is the attached to it is number 4. But why you do this numbering? No, I need to number them from the side that the carbon atom will take the smallest number. So I number them from 1 to what carbon atoms I number? I number the carbon atoms of the main compound, which is pentane, which is the longest chain. So 1, 2, 3, 4, 5. In this case, I get the carbon atom, the minimum number possible, which is 2. So we write it 2-methyl pentane. 2-methyl pentane. And I hope that is clear. We can add more examples, but if you still have a problem in numbering and naming, you can add many examples after you finish the questions related. You can add or generate more alkane than you name them. Okay, related to cycloalkanes now. We're going to move to cycloalkanes. Cycloalkanes, as we said, if I have this one here, this one is called what? Cyclobutane. Cyclobutane. Okay, this cyclobutane now, and we know in each corner there is carbon atom, but we didn't write it, and all of them singular what? A single bonds. Good. If I link this carbon atom by CH to CH3, what will be this one called? Look, the main compound is the cyclo one, which is cyclobutane. But what is attached to it? What is attached to it is this one. And what is this one called? Since it has 2 carbon atoms and 5 hydrogens, so that means this is alkyl. This is what? Alkyl. And alkyl, it is like alkane, but minus 1 hydrogen. And this hydrogen is missed due to the bond of attachment. So here now, this one, since it has 2 carbon atoms, so this one is called what? Not ethane, it is ethyl. It is what? Ethyl. So this one now is the ethyl, and it is attached to what? To the cyclobutane. So that means I name this one here, all of it. I name it what? Ethyl. That is attached to what? To cyclo what? Butane. To cyclobutane. You see? Ethyl cyclobutane. Okay, do I need to number the carbon atoms here? No, because if you number them, in general, this one will be number 1 because you start by it. So no need to write it here. Whether is it here or here, it's going to be the same. So that means just we said ethyl cyclobutane. Okay, we're going to give you another example here. If I give you 1, 2, 3, 4, 5. Okay. And I attach this one here to, for example, Cl. And this one here into what? Cl. What do I name this one now? What do I name this one? By the way, this one is called chloro. Chloro. Get. In this case, what do I name it now? First, I need to understand how many carbon atoms here on the cycle 1. There are 5, as you see, 5 corners, so 5. So that means this is now is pentane. This is pentane. But what type of pentane is it? It is cyclo. It is cyclopentane. Get, this is cyclopentane. What is attached to cyclopentane? Chloro. How many chloro? How many chloro? 2 of them. If there are 2 chloro, we call them dichloro. We call them dichloro. So that means we write here, dichloro. Dichlorocyclopentane. Dichlorocyclopentane. Get dichlorocyclopentane. Thank you. But these dichloro, which is 2 chlorine, 2 of them, they are attached to what number or what carbon atoms? So that means these ones you need to number them. So when I number them, I number this one number 1 and number 2. So you write here 1, comma, 2. To separate numbers from numbers, you separate them by comma. And numbers from letters, you come them by the hyphen. So that means 1, 2, dichlorocyclopentane. And I hope that is clear. Okay, another one. If I have here 1, 2, 3, 4. I'm gonna try to make them 6 here. 1, 2. Okay, they can be 1, 2, 3, 4, 5, 6 here. So this is now hexane. And since it is cyclo, we call it cyclohexane. Okay, if this one now is attached to CH3, and this one now is attached, for example, CH2, CH3. How do I name this one now? How do I name it? First, the main compound, which is here, what is it called? It is hexane. Cyclohexane. Good, thank you. Now, what is attached to it? This one and this one. And what is this one called? It is called what? Methyl. It is called methyl. And what is this one now? It is called what? Ethyl. And you understand why? It has 2 carbon atoms, that is ethyl. 1 carbon atom here, it is what? Methyl. Good. Now, when I have ethyl and methyl now, they are both of them attached. Which one I write first here? Methyl or ethyl? Okay, look how I write now. You go to see the letters alphabetically. Which one comes first, M or E? E comes first. So that means I'm gonna write ethyl first. I'm gonna write what? Ethyl first. But ethyl now, on which carbon atom? In which carbon atom is the ethyl? So that means here you can number them from 1, look, 2, 3. So this one is number 3 and here number 1. So that means 1 ethyl. Okay, then as you see the separate letters from numbers. And then what comes to one number, what? Number 3. Number 3, what's there in number 3? Is what? Is methyl. Is what? Methyl. So this one now, as you see, it is 1 ethyl, 3 methyl, cyclohexane. Cyclohexane. So you understand now how to name them when they are in cyclo shapes like polygons. We understand them, and also whether they are straight lines. And we gave many of them, and you have other examples on the quiz to do them. I hope that is clear, and pay attention. This video is the main video in organic chemistry. So that means if you understand it perfectly, other ones will be easy. If you didn't understand it, you need to repeat it 1 time or 2 times or 3 times to make sure you understand it fully. Before you go to the next videos and the next parts, make sure you have a solid understanding of this video. Thank you. See you in other videos. Goodbye.